Hello, everybody. So my name is Gauthier Falconet. I'm the Vice President of the Car Connectivity Consortium. And I will make an overview of what are the car connectivity activities and what is the MirrorLink technology. Okay, so here is the agenda. So I will start with the landscape for smartphone integration into cars. So what are the hints that, that comes in mind when we want to have a smartphone in the car? I will present the car connectivity consortium activities. So what do we do in the consortium, how the consortium works. And so the consortium is in charge of the development of the MirrorLink technology. So I will present you what is MirrorLink. And I hope when you will go out of the room, you will have a good overview of what's the MirrorLink technology and what it enables with your business. I will also present you the certification and why we came to this idea of certification and the concept we have around bringing apps in the car through MirrorLink. So first of all, some insights. So cars are getting more and more connected. And consumers want cars that are getting more and more connected and use case to use connectivity through infrastructure, other cars, machines, cloud. We can think also about eco features. All these features and maybe more are requiring connectivity in cars. And people want to be connected, but not only connected, but connected everywhere. They want to be always online, always available. And when people don't have connectivity, they feel lost. And now it's getting in the usage that you want to be able to be reachable everywhere, and you want to have all the applications you have in your modern life everywhere. But when we think about standard smartphone connectivity solutions, they are standardized everywhere. Wi-Fi is a standard, USB is a standard, NFC is a standard. But when we are talking about bringing apps in cars, we can have plenty of solutions that most of them are driven by a car vendor. And so for an app developer to bring the phone application in the car, they have to address every single way, every single car manufacturer and say, how can I integrate my car in your app? And they have to adapt themselves to each single solution that are proprietary. Some other insights, if you build application for in-car use, you will focus on safety. Of course, we all want fewer distracted drivers on the road. And developing an app in a car is something unique. And it's not the same thing as developing an app in a phone or for other applications than in a car. It requires some UX design that is specific to what you are doing. And so this leads to the fact that application must be specifically designed in terms of HMI to be built in the car. And when people want to build application for in-car use, they will have to follow guidelines that are written by the government. And these guidelines are, most of these guidelines are focusing on the car manufacturer activities. So they are very complex to think, they are very complex to apprehend, and this is one of the problems app developers can face when they want to develop apps in cars. Also, smartphones are evolving fast. The connectivity we can see from 2G, 3G, 3.5G, LTE, and I'm quite sure that within a few years there will be a new technology coming that will be more faster, everything. And it's very hard for applications that are in the car for 10 years to follow this kind of evolution of connectivity. And also applications, there is a new application every picoseconds. And to have this application integrated in car, every picosecond is strictly virtually impossible. And new services are coming every day. New people are coming with new ideas. And to get these ideas concrete in a car is also something that is a very big challenge. So car industry and handset industry came together and say, okay, we have different product life cycle. We have, on the one side, a lot of application available. On the other side, we are willing to provide this application to our consumers. And altogether, they thought how we can bridge these problems together, how we can solve this problem together. And from what we saw before, we can really feel that we need to have a different approach and not standardize interfaces. So this is where Car Connectivity Consortium comes into place. So what is Car Connectivity Consortium? It's a global consortium that is developing smartphone-based connected solution. So it's an open consortium. Every company that is interested in giving inputs, that is interested in developing a product, that is interested in developing apps, are free to join and to help us in this task. And what's interesting also is that the solution, MirrorLink technology, is not something owned by one single company. It's many companies that come together, and as soon as a new company comes, they are free to propose new use cases. They are free to implement the MirrorLink solution. Every company that is in the consortium are free to do this kind of things. And they are free to implement solutions, and whatever their OS is, they don't have to have some, the app developers don't care. They are developing for a platform, and they want to have this, whatever the platform is, they want to have this in the car. So the solution, the MirrorLink solution, is OS agnostic. We don't mandate any specific OS. And we provide to both device makers, so phone makers and car makers, and head unit makers, and application makers also. We provide certification to all these parties to ensure that the solution will work, and it will work with, and it will solve most of the points we see previously. So the Car Connectivity Consortium is bringing cars, handset, head unit industry together with app developers. It was established in February 2011, and since then we have a rapid growth. We are now 85 companies in the consortium. And if it was only very small market share, we would find any of these proprietary solution competitor. But we represent 80+ global market share in the automotive industry and 70% of the smartphone industry. So this is really all the companies, the car companies, phone companies coming together and trying to find a solution to bring apps in cars. And we define MirrorLink as the open industry standard for smartphone integration. And MirrorLink is the technology developed by CCC. We can see a few of our members. You can see all the car makers are here, most of them. Phone vendors also are here. All the relevant are here. Nokia, HTC, Samsung, Panasonic, LG. There's also BlackBerry and others. On the car side, GM, well, you can see it. It speaks by itself. We have also a navigation solution provider, app vendors, labs, aftermarket head unit provider, a tier 1 to car makers. All these people are members and are working together to make it possible to bring apps in cars. So what differentiates MirrorLink technology with others technology? So MirrorLink technology is, I take my phone, it has MirrorLink on it. I have some application I have downloaded that I've seen that they are MirrorLink certified. I bring my phone in my car, and I get these applications that are executed on the phone in the car. So it's a replication, a mirroring of the phone in the car. But what's very interesting about this, it's not the phone UI. It's the phone UI adapted for the use in the car to address the driver distraction concern. And it enables, because it's mixing handphone vendors and car vendors, it's mixing also controls that are existing in the car. And actually, it's all the application that are, the application, what you must really understand is they are executed on the smartphone. So the and the head unit is, the car is only rendering what's executed on the smartphone. And it relies on the USB, Wi-Fi, and Bluetooth to do this transfer. And when you see this image, you really understand that it's a pixel per pixel copy. So when an application is MirrorLink compatible, you will expect to see the application on the head unit side in a special HMI that is adapted to drive mode, but it's the same application that is running on the smartphone that you will have in your device. Here you see that the guy is taking the phone, but of course, the phone is off. And the user is interacting directly with the screen of the car. So meaning that if it's a touch-based interface, he will use the screen of the car to control the application that are running on the smartphone, but he will not have to touch any time the smartphone to control the applications. So where we are right now, in 2011 we had aftermarket products. We can see in the first wave some Sony devices on the head unit side, some Alpine, GVC Kenwood. They developed the first aftermarket for in-car. On the phone side, we have Nokia supporting MirrorLink in the Symbian Bell and MiGo OS. All phones are supporting, that are on the OS are supporting. And Samsung is supporting it on the Galaxy S3. And also Panasonic and Sony. We have currently, so I mentioned that the device, so both the phone and the car head unit has to be certified. So we currently have 261 product variants that are certified both on the handset and the head unit side. So on the unique implementation, it leads to 11 products and 17, and the others are variant of products. What you must understand from this, it's only for the first version of MirrorLink. And these products that are certified are waiting only one thing to come in the market is MirrorLink 1.1 specification, 1.1 process. And so in 2013, we will see the first bunches of products, both on the phone side and in the car side, to be in the market. And in 2015, the volume will come. So business-wise, what doesn't MirrorLink do? We don't differentiate middleware. We are middleware agnostic. We don't differentiate connectivity side. We don't differentiate in user interface or operating system interface. This is all controlled by both the app developers or the OS vendors. This is not where we stay. MirrorLink is about allowing application to provide the differentiation. We don't provide you a fixed HMI that you have to follow. You don't need some special infrastructure on your side to bring your apps in the car. And for you, as soon as your application is MirrorLink certified, it will be available on every car as soon as the user has a car and a phone that are certified against MirrorLink. So for you, you only have to develop once an application, and it maximizes your ROI. So this is an open and generic approach to address the use of application, and it's a way also to address the driver distraction concern. Because as I will show later, driver distraction is one of the main concerns that we are all taking seriously. And we are offering a solution to solve this problem. And MirrorLink doesn't conflict with embedded automotive solution, but complement them. We are adding new features, new applications that weren't currently available in the market, in the cars. And the CCC is here to build and to make this possible now. So if any company is interested in joining the CCC, as I told before, everyone is invited, and to provide feedback or guidance and to start implementing products. But as I said before, driver distraction is one concern, and phone applications, they are not designed to be used in the car. When we see a phone in the phone mode, even if it's landscape, you see there is some small text, the graphics, some small images. It's very hard to address it while you are driving and where your first task is to focus on the road. So what we are providing is the way that the phone can be aware that it's executed in the car, and the phone UI can switch to a car mode. And every phone application that will be drive certified will be able to switch in this car mode when it's connected through the MirrorLink. So meaning that when an application executing on the phone is MirrorLink drive certified, it will provide a safer usage than right now when the user is doing this on the cell phone. And for this, we are developing UI guidelines that are based on the European Commission guidelines, American guidelines, and Japanese guidelines. We are developing these guidelines to make them available to the app developers. Because as I told before, these guidelines are complex to apprehend, to manipulate, and we are extracting the essential information for app developers so that they can bring apps in cars that are following these guidelines. And we are providing the mechanisms to certify application. So as I told before, leverage down the distraction that we are doing to the driver, and this is done to the common application development guidelines for in-car apps, as I told before. And for app developers, the second part, if they don't want to handle this certification part, and they want this process to be as transparent as possible. And for that, I will show you in the next slide. We are targeting the launch in the first half of 2013, the delivery of the application certification system to the market. So applications will be categorized in three kinds. The first is the application that are not aware that MirrorLink exists, that doesn't have these few APIs. And for them, it's like Angry Birds, okay? They are not safe to use in the car. They are designed to be used outside. It's all the outside world. When an app developer wants to develop an application for MirrorLink, the first level of certification is base. It's really to ensure that the application is switching to the car mode, so from portrait to landscape, for example, and that the certificate is present, and it's really the base level certification. The second level of certification is when an application is base certified, it will be able to execute while the car is stopped. It doesn't have this driver distraction constraint. But the drive certified application will enable the application to be executed in car while driving. So, and it will ensure that for the end user, for the car vendor, for the handset manufacturer, and for the app vendor, that this application has been tested against the driver distraction guidelines. So the CCC is building what we call ACMS for Application Certificate Management System. Sounds complex. But in the end, what the app developer must know, he just provides the application to the application store whenever he wants. He contacted the server to say, okay, I want to provide this application to be MirrorLink certified. He contacted test lab to say, okay, I have now followed the guidelines that will be available. I have now followed the guidelines for my application. It behaves correctly. I think it's now time to test with independent test lab. So the independent test lab look if the application fulfills the driver distraction. And if it's OK, he provides this information to the SEMS. So for the application developer, for him, it's OK. Now, when the phone will get the application from the application store, the application will work in the car that are MirrorLink certified. So if both head unit, phone, and in addition, the applications that are in the phone are MirrorLink certified and MirrorLink Drive certified, then this application will be able to be shown in the head unit. So we are really an open consortium, an open forum. And any company that is willing to develop MirrorLink, either application, device, or to provide new use cases are really free to join. And we are not a connectivity solution, as I said before. So we are the open industry standard for smartphone car integration. We are proving access to smartphone apps, to car data, and this is very important, is the application, when it's in the car, executed in the smartphone but rendered in the car, it will be able to use the GPS coordinates, if available, in the car from the rooftop antenna. So the GPS coordinate will flow through the head unit to be available through the smartphone to the applications. So this is very important. And this pipe that is generic will be able next, if decided, to provide more information regarding car data. We also provide a common application development guidelines for in-car apps. These guidelines include driver distractions, and they will include also the API that the app developer will be able to add to their current application that is running on the smartphone to know that it's in the MirrorLink context and to be able to switch from this phone mode to car mode. And the certification process, as you saw before, is completely transparent for the app developer. They just have to apply when they think they're ready against the driver distraction guidelines. And as soon as the app is tested, the app is on the market because it's already on the market, and it's then available to the end user. So this is very important that all this certification process is transparent for the app developers. Otherwise, it doesn't make sense. So we have two versions of MirrorLink, the 1.0 and the 1.1. The current products are available in 1.0. The one coming will be in 1.1. So if you want to have an idea of technical aspects of the MirrorLink and what needs to be done in order to have to be the basics of MirrorLink, feel free to go to this page, download the specification, have a look, and we are hoping that you will join the CCC to implement the latest version. As CCC, we are having 3 meetings a year. So these meetings are a way to exchange during working groups, on technical working groups, for technical aspects of the implementation of the MirrorLink, for the certification on the certification process, and the ecosystem and user experience are really focusing on what's next, what's the new use cases, what should we enable. And as the CCC is not focusing only on MirrorLink, but is open to any additional technology that we can use, then it's really in the UX, user experience working group, that these new use cases are bring by members, and if approved, then they will be implemented in the technical working group. We are also organizing an IOP test event against just to ensure that all head units will work on all phones, so real test field testing. And we are having also technical workshop to focus on the technical points development. So if you want more information, please visit our website, mirrorlink.com. Any questions? Questions at careconnectivity.org. Very easy. Feel free to speak to any one of us after the presentation. We also have a booth, one level up, same place nearly. If you want to know the number and if you want to pass by to see real products that are implementing MirrorLink, it's 8.1 J21. And this afternoon at 5:30, or 5:30, there will be a cocktail here, and it will be also a good moment to exchange about MirrorLink technology and all the things you have in head. Thank you very much.
Good afternoon. As he said, my name is Robert Hrabak from General Motors, and I'd like to welcome you to our afternoon presentation. I'm here to speak with you about the automaker value of MirrorLink and bringing your mobile life to the road. Before I get started, a little bit about myself. I worked for General Motors for 3 years now, but prior to, my career has bounced around from a mobile device manufacturer to Tier 1 automotive to silicon provider for mobile electronics. And so from that broad expanse of understanding mobile devices, consumer electronics, and how they integrate into the automobile, I'd like to talk to you a little bit about that today. As we get started, let's talk about what infotainment used to be. One app, one AM/FM radio app for going on 50 years. The company figured out how to stick an AM radio tuner on voltaic cells into a car. The first car radio was born. And this, for a long time, this was the killer app of infotainment. As time went by, that changed though. And automakers evolved their electronic systems, integrated more complexity, instrumented their vehicles more highly, and soon navigation was the premium option for infotainment and electronics for all of automotive globally. And to this day, it's still oftentimes marketed as the highest package that we have in our vehicles and is what differentiates the premium automobile from the rest. But infotainment hasn't really been strictly limited to the automobile. In reality, the smartphone, your mobile life is nothing more than infotainment above and beyond the car. It's the infotainment for the rest of your life, the 80% of your life. And take me, for example. Each day I commute 45 minutes each way to and from my office. In doing so, I spend an hour and a half a day facing my vehicle infotainment and 8 to 10 hours a day facing my smartphone infotainment. That said, there's much more user value, user credit, and user familiarity in the smartphone electronics, in your infotainment for mobile life. It's with this that we look to enrich the automobile through MirrorLink. And with that, we look to bring mobile life to the driver. As mentioned before, consumers expect to be continuously connected to their consumer electronics. We see it everywhere we go. And we have, at this event, we integrate our mobile electronics as our badges. At work, more and more companies move from integrated phone systems to mobile phone systems. Telecommuting is quite common, and consistent connection is what the consumer demands. This doesn't change while driving, and so as automakers, we have the opportunity to either restrict this or use this to complement our products. And that's why we look to MirrorLink. MirrorLink connects the driver through smartphone applications responsibly while driving. So let's take a look at the customer value of the mobile life behind the wheel, because after all, when the customer sees value in a vehicle, they buy cars. This is, first and foremost, an automaker's primary business, selling cars. When we integrate a new feature into infotainment, what we're really looking to do is make the consumer say, wow. blow them away, show them something that they must have. And one can do so with MirrorLink in a few simple ways. I get into my car, and my apps are all there, ready to use. The notion of simplicity, quick to connect, obvious to connect consistently, and use for the entire length of my drive. My apps work the same in my car as on my phone. They just look a little different. As said before, the user spends 80% of their day facing applications in a PC or on their phone. Why then do we add more complexity and make these look wholly different? Why not leverage the familiarity that they already and comfort of features they already know? I can always use my favorite apps. Simple integration, simple growth of content. We'll come back to that some more. My infotainment system is always up to date. And for those of you who've purchased quality infotainment, I'm sure there's been some concern about this over the long case as well. And lastly, my apps work just as well in my car as they do in my spouse's car. Consistency, reliability, familiarity. We'll talk about these pretty readily as consumer values. First of all, the ease of use, simple connectivity. MirrorLink is built on traditional connectivity technologies we find in automotive. USB is proliferated every consumer electronics device we know. And what better way to manage it in the vehicle? High-speed connectivity, power, and a technology the user is familiar with. Similarly, we also support connectivity over Wi-Fi for the seamless experience. The user gets in and their apps are just there. No connection, true seamless mobile life from the human space to the vehicle space. The next ease of use factor then moves to the applications themselves. Application user interface is what is the brand image that an app has to the consumer. Similarly, it's a product differentiator, and it is an experience enhancer. And through MirrorLink, we hope to bring the same features, the same content that the user sought out in their applications and share them through the automobile with remapped controls and for purposes that complement and enhance the drive itself. So let's take a moment now and look at a couple of sample users and the content that they may have. Right now, on users, smartphone owners install new apps on a daily basis, weekly basis, monthly basis. Their content portfolio grows and changes based on what their needs are. If we look at owner one, this is now the opportunity using MirrorLink to grow the feature content of their infotainment system. And the vehicle itself increases in feature value over time with the growth of content on their smartphone. Owner two, a little bit different. We notice that there's a more continuous state of some apps available through MirrorLink. That's not to say that the value isn't growing, but it's tuning. MirrorLink offers the opportunity for the user to tune their infotainment experience over time and actually make the infotainment as personalized as their mobile device. Maintaining that value in the long run to a vehicle owner is also quite important, both in terms of long-term utility of the vehicle and in terms of resale value. And so if we start comparing ownership cycles between vehicles and consumer electronics, we find that there's a pretty significant mismatch. In the US, typically consumer phone ownership cycles revolve around standard service contracts. typically around 2 years. And so what we find is that every 2 years, some consumer devices change. In vehicle ownership, the model is a little bit different. Of course, there are vehicle lease options, which can, in the best case, assuming you bought your phone and your car on the same day, have a very nice one-to-one matchup. Or, the more common occurrence is a mismatch. And what we then find is, in the course of owning one vehicle, a user may have 2, 3, 5 different phones, or multiple phones, which wasn't even addressed in this. And so what we see is, while in a given owner's vehicle ownership period, they have, in that purchase, we want them to be able to feel confident that their product will be of service to them over time. We already talked about how, through the smartphone, the user can grow their infotainment feature contents. Now, we can ensure them through the ownership of that vehicle that through backwards compatibility of MirrorLink, even when they change their phone, their infotainment experience remains the same. We looked at our membership and we realized that there's a tremendous amount of automotive brand representation, which also adds value to the consumer. By MirrorLink acting as a standard, as a single way to bring apps from the phone to the car, it offers the opportunity to extend this same infotainment experience wherever they go. It's no longer a custom infotainment experience in their car. It's a custom infotainment experience in any car that supports MirrorLink. Let me give you an example. Each day I drive to work in my quality GM product and drive home. And this is my average commute. I value my infotainment in my vehicle. But maybe for some reason I have to attend a conference in Barcelona, Spain. And when I arrive at the airport, my only options are Seats. Well, I've spent my time with my infotainment with MirrorLink. I know the apps I want, the apps I need to get to where I want to go and do what I want as I'm driving. I now take my phone out, connect through MirrorLink, and my infotainment, the one I know and I'm familiar with, is available to me as I'm driving around a place I've never been before. To a consumer, that's power. To a consumer, that's freedom. To a consumer, that's the integration of mobile life in the new mobile horizon. So I spent some time talking about how the consumer can find value with an automobile equipped with MirrorLink. I now want to transition over towards the automaker and how we realize this value independently of adding feature content to our consumers. Now, infotainment development, automotive development cycles in general, are rather long periods, typically 2 to 3 years historically. In the consumer electronics space, this is interminable. Consumer electronics are conceptualized, developed, and launched multiple times over within one infotainment development cycle, which means that infotainment designers have to study and forecast technology models that haven't even been thought about by a partner. It's a guessing game. It's an educated guessing game, but it's a guessing game. And what it inherently can do is slow down the development of features to the consumer. Now, this inhibits the integration of smartphone technologies and applications into the vehicle, thus giving an otherwise extremely fast ecosystem surprisingly long lead times. And in infotainment's case, once an infotainment platform is out there, given those same long lead development cycles, all one can do is software update and software integrate and software change on that same platform until the next one goes through. This goes back to the beauty of standards-based connectivity. in MirrorLink. MirrorLink, using Wi-Fi, using USB and Bluetooth, offers the opportunity for a software change to actually grow an existing infotainment hardware platform. This is tremendous to automakers because that means that it comparatively is a rapid time to market feature we can add. And it's a feature that keeps on giving, as we discussed before. Similarly, just as we discussed backwards compatibility as a feature for the consumer, it also is for the automaker. It ensures that the devices that are yet to come, once our development cycle has been initiated, will continue to work with our devices after launch. What's most interesting about that notion of backwards compatibility and interoperability is it's something that MirrorLink, as a standard, has protected for in the technology. Not only is it designed for backwards compatibility and interoperability, it's required for certification. And this is the next big value add to automotive. Every automaker that has connected infotainment struggles with the variations between device implementations to which they connect. And this is a cost that is absorbed in each product cycle time over time. Rather than repeating this based on variations of implementation, subtleties, unexpected technology quirks, MirrorLink focuses on the use case of sharing smartphone apps from the phone to the vehicle. And in doing so, it's very easy to test the successful rendering of that. By consequence, as an automaker, we gain value by earning our certification, proving our interoperability with devices on the market and those yet to come, and building value to the automaker by reducing customer complaints and customer impact to usability. So once we now have certified smartphones, certified infotainment systems, we have a interoperable global open platform for applications. This is powerful. And now we need to figure out how best to bring our apps into this platform. As was mentioned by Gauthier, the CCC now is beginning to engage and certify applications as MirrorLink-based certified applications. Just as we discussed the interoperability from device to device, so too we want the Car Connectivity Consortium wants to certify that same notion of interoperability and scalability across different smartphone infotainment combinations. And with these two certifications of interoperability, we can protect and ensure our customers, both our smartphone and our infotainment and our application customers, a consistent application usability in the vehicle. We've taken the guesswork out. We've taken the mobile life and brought it into the user's dashboard. But before we go too fast, we always have to think about limits. When driving, we talk about speed limits. Well, in infotainment, we talk about driver distraction. And I had the opportunity of living in San Diego, California, when legislation was passed legally banning the use of handsets while driving. And so it was an interesting phenomenon. You could observe an interesting phenomenon just walking around the streets. Historically, you would see people driving like so. One hand on the wheel, one hand on the phone in the peripheral vision of the driver. Probably not the most responsible. After legislation was passed, drivers went from this to this, doing nothing more than concealing the fact that they were using their handset while driving, dropping it below the window line. At the same time, rather than having their peripheral vision on the road, their eyes now drifted completely away. Regulation tends to bring up challenges to enforcement and consistent behavior. Remember, the consumer wants to constantly be connected. So what can we do to compromise and come to a place which connects them while being responsible? Automotive is focused on reasonable infotainment driving techniques, or infotainment UI development for driving for many years. Enough so that three independent alliances globally have formed around industry practice guidelines. The European Statement of Principles, the Alliance of Automakers Driver Distraction Guidelines, and the Japan Automakers Association Distracted Driver Guidelines. With representatives of automotive from around the world participating in the CCC, we've worked to hone in on these, study them, combine them, refine them, and build what is now the MirrorLink Driver Distraction Guidelines, the cookbooks for making an app infotainment friendly and drive safe. What this has done is provided us an opportunity to harmonize these three different guideline documents and present them in a more constructive manner rather than a test-based manner. What this has ultimately done is given us the ability now to help structure a way to make app UIs look useful in cars. And moreover, it also has provided us some clear testable concepts, not requirements so much, but structure in which we can begin to start assessing how much workload is put on the driver. How much of their brain is needed to focus on accomplishing whatever it is that they want to do through infotainment. Whatever task is at hand, so to speak. And with this task measurement, we can now assess whether an app is reasonable to drive with or not. And so what we have, those same apps that are infotainment for mobile life, now can be verified as not so impacting to the driver. And what we get over time, as we test the apps that are in the mobile space and the apps that are yet to come, is a growth of applications which are accessible to the user while driving. This is what we ultimately assess the consumer wants, the ability to pick the best solution for what they are doing while driving, whether it be navigating, whether it be following someone down the road, whether it be listening to your favorite radio station. Hey, guess what? Our first infotainment app is now a perfectly relevant MirrorLink infotainment app. And ultimately, through the interoperability of MirrorLink base certification and the managed risk of MirrorLink Drive certification, we can provide apps to users while driving in a constructive and helpful manner that complements the drive rather than distracting from it. To recap, the automaker's value of MirrorLink comes first from its consumers in the fact that it brings smartphone apps to the user while driving. It brings value to the automaker in the development process by making their development efforts more relevant, easier, and lighter in the road to productization. And it provides a good alternative to using a handset while driving, with providing the same features and value to the driver at the time. Ultimately, MirrorLink promotes the use of apps that complement the drive rather than being distracted from it. Thank you very much. At this point, we're going to open up the floor to a discussion panel. You notice the two gentlemen who have been here listening intently, I'm sure. I'd like to introduce, first of all, nearest to me is Jörg Brackensick from Nokia. And to the further side of me is Alfred Tom from General Motors as well. Again, this time I'd like to open the floor to questions as they may be on topics of automaker value of MirrorLink or other topics that play in. And to get things started, though, I guess I'd like to ask you both the first question. While we talk about adding value to the automobile through smartphone applications, does that inherently reduce the value to the smartphone maker themselves by no longer having the customer-facing experience?
No, as from a smartphone manufacturer perspective, there is a lot of value in having applications being utilizing MirrorLink, because as you pointed out, so if our consumers, our customers, stepping into the car with their smartphone full of application content, there is no use in the car while driving. So having MirrorLink is from a device manufacturer perspective the best bridge to actually allow our customer to extend the use of their favorite applications also in the drive situation. So it's the same as you describe it as a plus from your customer perspective. It's a plus from our customer perspective. At the end, they're the same customer, right? So it's the same person driving his car with his phone. So there's definitely a big value in you being able to utilize MirrorLink in the setup.
Other questions from the floor? We do have a microphone. If you have a question, just raise your hand.
So, from your perspective, what change do you see does MirrorLink bring to the way that a classic in-vehicle infotainment system is, or functions in the system, are going to be implemented in the future?
I can comment on that. I guess it depends on what type of infotainment system you have. The older infotainment systems, usually have built-in applications, navigation, climate control, radio. Integrating MirrorLink into that scenario is a little bit more simple. It's merely adding more quote icons to the user interface that access MirrorLink apps. There might be a little more difficulty integrating MirrorLink with infotainment systems that already have some type of app concept behind them, and that will take some creativity from the automotive manufacturer's perspective into making a consistent UI that makes sense to the user, how they access the different apps and the different application frameworks.
My question is around business model between the apps providers, the device manufacturers, and automakers. I mean, somewhere have you thought about, as MirrorLink, I mean, what type of business model, if I produce and develop apps, so I want to be an integrator in that space. I mean, what business model? I mean, let me give you a practical example. I come from an area in South Africa where GM is there, VW is there, Mercedes is there as auto manufacturers, and we develop apps in the same area for mobile operators, and we see this as an opportunity. What business model would be there between these three different areas that you envisage?
Maybe you can start, and maybe I can jump in. So if you look back into the kind of the last 2 or 3, 4, 5 years in the smartphone side, so when SmartPhoneWise is offering a platform for app developers to start, what you see that the value from a device manager perspective was that you offer a platform which is easy to use for app developers, and the better the platform is, the more app developers you attract, it's a value for you as a device maker. So we see now with MirrorLink for the best opportunity to step into the automotive space from a device manufacturer which so far has been closed to us. So therefore we see if we are able as a device maker to offer a good or the best platform for app developers to now develop automotive apps, it's an implicit value for the device maker perspective. Because now we get better apps to our devices, which can be used while driving, and thus may make our platform as a device maker more attractive than other platforms. So I see similar use case and business model as you can argue why we have smartphones and why we develop apps for smartphones. I see this similar ways, just another domain which opens up now for app developers with the automotive domain.
Yeah, so I can comment from the perspective of an app developer. So I see that there's going to be two types of ways to monetize applications in the car. Firstly, it's more of a distribution model, right? So you're an app developer, you offer some type, let's say you're a big data company, and you want to collect data about consumers when they're using their smartphone. The automotive environment could be another data collection mechanism, right? So eventually MirrorLink is going to offer ability to get data from the car. You could collect that data, put it in the cloud, and offer data services and data analysis to people. That's an example of how you extend a business into the car environment. There can be also, I call affiliate business models, where you offer a navigation system, but you have a unique way of suggesting or encouraging consumers to use certain services on the drive. For example, shuffling people over to a charging station when they're low on electricity or low on gas, for example. You can collect an affiliate fee for sending people to a gas station, or even higher affiliate fee for a hotel. Some hotels spend $5-10 for each referral, and that's significant. OpenTable makes $1 per person when you book a reservation through OpenTable. So there's a lot of these models, and eventually we'll get to the point where a lot of the services that you see in the smartphones, like banner ads, interstitials, and whatnot, those will be available in the car environment. That might take a little bit longer because you can't throw banners at customers when they're driving, but maybe there's some kind of voice prompts or something creative that might happen later on.
Hi. One of the things I wasn't clear is, does MirrorLink address the back screen as well? So obviously there's all this safety of the driver distraction, but what I would like to know is, what about if I want to access some media on my phone? Now I understand the driver doesn't want to see that, but maybe the kids at the back do. Does MirrorLink address that currently? So
as you pointed out correctly, so MirrorLink is primarily focusing on driving a driver-facing display. As part of the technology, what we're using, so we're using IP technology, so meaning we create a link which is based on IP. Of course, you can use that link also to distribute content to other screens. I think the challenge is to make it work for the driver-facing display, because all the regulation and the constraints you have in place. So it's much easier to handle with respect to backseat entertainment system. On the other side, you have to understand as well that on the backseat, people just put out the iPad and use the media they have on hand, which is not possible for the driver-facing thing. So it's yes, you can approach it with the backseat. But the use cases is getting thinner.
It's a really obvious question. Why hasn't there been more focus for driver-facing displays on heads-up displays, which actually come on the windscreen in the driver's field of view, translucency?
It's an extra piece of hardware for manufacturers, and if you look at the heads-up displays and you see right now, they're mostly LED, LCD-based type screens, so there's not as much flexibility. I definitely see it will come at some point. There's no reason why you can't do it, but at this point, let's get the easy win first, which is the center console screen.
So cost and technology, basically.
Yeah, it's definitely possible.
And what I would see that those heads-up display is sort of can provide complementary information to what shows up on the main screen. So if you, for example, if you go you use navigation, you can see the maps on the big screen, and you get see some of the guidance error on the heads-up display. So I see that as well. So it's a possibility to combine both experiences and have it complementary to each other.
Other questions?
Let's give him the mic first.
Because I visit the show floor, and like other companies, they try to build all those communication devices like the iPhone type inside the car. Like we visit some leading brand name company, equipment company. So how do you that this kind of standard with them? Because obviously it approaches the same car manufacturer, so they must make a choice. Do they want to using this your standard interface, or they try to build in? Okay, they do both.
Well, I think the question is, what solution is better, to put a docking station inside the car?
Inside the car, like you put
Yeah.
the phone, you put the phone, right? Or you have the outside phone. So my question is, in the car industry, they must select a solution, right? They cannot a car equip with both options. So how do you compete, or how?
I see them as complementary solutions. So I think from a car maker's perspective, you cannot rely on the consumer to bring in a certain type of device, right? So, when General Motors first looked at the technology, it appeared very applicable to the lower end, maybe some developing marketplaces where not everybody has an iPad or a device themselves. So you can't rely on it. That being said, it is a pretty nice solution to have a docking station as well. Maybe more for rear seat entertainment, maybe not for the front seat. But that's because in the front seat, you have to concern about the driver distraction issue, right? You can't just let any movie or game to be playing in the front seat. So I don't think it's a solution for the front seat. Of course, some countries don't have that problem, right? You can watch movies in the front, but
Okay, thank you.
Which actually is a good point to bring up. MirrorLink has planned to address some key regions as we identified: Europe, EU, North America, and Asia Pacific through Japan, Japanese-based driver distraction guidelines. But that's not to say that these are the only regions that one has to, nor is it to say that granularity is as small as it will ever be. And so it is plausible that if there are other levels or lack of regulation, that from a productization standpoint, maybe it's a good practice, but not a necessary requirement.
Running out of batteries?
I don't know. No, okay. Perfect. One question. Has the MirrorLink the capability to take data from the car and provide this data to the apps?
Yes. So what we have in our latest specification is the basic mechanism to exchange data, which is available on the car to provide it to the phone, and the phone is then going to provide it to the interested apps. The concept what we have actually is works in both directions. So actually also the head unit could subscribe using that mechanism to data which is sitting on the phone if it wants to. So we have those mechanisms in place, and we have started already. We have 2 location type services already available, and we are working at the moment to expand this provide access to other sorts of car data. So all the mechanisms are in place, the protocols are in place, the formatting are in place, and what we're doing right now is step by step defining those data services and get them integrated and specified so that apps can subscribe and use those.
And another question. This data, for example, should be the same data that has in the instruments panel? What they say, the car manufacturers about it? To, for example, provide some type of data, for example, consumptions or this type of data?
Yeah, I think it's going to vary from OEM to OEM. You know, different OEMs have a different attitude towards it. Some are going to be very open. They're going to give everything up. Some OEMs may be a little cautious. I think the general trend will be towards allowing more data. It's just some companies will get there, before others. And then there might be varying aspects of access control, right? So, if you have a web service RESTful API, you're not just going to let anybody access that RESTful API in high volumes. So you might have some type of access control technology that controls that a little bit. Yeah.
And then the mechanism will be similar to the OBD? It means you have a standard EDs to ask for information and then provides information on, or each manufacturer has their own solution to take the data?
Right, so OBD is an example of an interface where every manufacturer is a little bit different, right? And within a manufacturer, every single model is different. So, you have really expensive OBD readers that, try to tell you what the car is telling you, right? So the hope is with MirrorLink that there'll be a standard, right? So for battery data, it's the same API, the same type of information coming across the MirrorLink connection. And that's kind of where we're trying to get to.
Because if you don't do, there's not much value for an app developer, because then it's, from an app developer perspective, the space of car data is hugely fragmented. And for app developers, the value is in reducing the fragmentation and have a universal interface to this. So that's the main purpose in try to work on the standardization part is, besides that some of our members may not open all the data, but if they open the data, there is a specific format for doing this. So they all comply. So speed is always giving in a specific format, and whether speed is given or not, that's a separate decision. But if it's done the same way, so that app developers actually can utilize that data without dealing with the fragmentation of what's the format.
Yeah, and this also is this notion of standardization or normalization is actually one of the biggest technical challenges to it. The example case I like to use, it actually goes back to the notion of interior personalization. It's automatically setting the driver's seat to the connected phone's position. Well, in my own car, I can adjust that, and it's very consistent. Every time it sets these X parameters. But let's go back to the rental car example again, where I get into a car that's built by an entirely different manufacturer. Now, in the physical space, the mapping instrument is the human. So how do we translate those human measurements into something that would adjust a Volkswagen's driver's seat to the necessary settings that I, as a Chevrolet driver, would need in my Chevrolet? Is that possible? I don't know. And that's arguably a worst case example.
Yeah.
But it's this notion of normalizing those parameters to something that industry-wide could use.
Hi again. You mentioned that you currently are able to support USB, Wi-Fi, or Bluetooth. Are you kind of technology agnostic? For example, if someone had a proprietary thing that you're able to work with a mobile phone vendor, and it met the physical layer requirements by you guys, is that something that you support, or does it have to be USB, Wi-Fi, and Bluetooth only?
So at the moment, those three connectivity solutions we have specified or we support from a standards perspective. We are not limited to it, so going forward we can include other types of connectivity solutions, and we're actually doing this. So we have with a new specification we are going to roll out soon. Actually doing this. There are a couple of things what we need as I think you pointed out that we're actually using most of our protocols are based on IP. So we expect that those technologies are providing a possibility to establish an IP channel. As long as we can do this, we don't care that much of the physical transport. It can be any type of transport. What we expect an IP, the possibility to set up an IP connection with a certain amount of data rates. And latency requirement. Yeah, latency is a big topic with respect to driver distraction, which translates as well into what's the available bandwidth.
Can I ask what's the bits per second minimum requirement?
We haven't done a real in-depth analysis on that, but maybe somewhere between 1 and 10 megabits probably would do it.
Above 10 would be okay.
Yeah.
Like 10. I mean, sorry, around 10 would be fine. Okay.
But that all depends on whether your physical layer is going to handle the graphics in a different.
Right. So if you take out the visual part, so the audio part is about a bit more than a megabit of data, one direction. If you have two directional, you're ending up with about 2 megabit per second for the audio part. Uncompressed audio, assume uncompressed audio. For the control channel, it's actually not too much. We have a bit of key events going from the head unit, from the car back to the phone. We have those advertisements, what Robert was referring to, the advertising applications. That's typically a one-time thing at the beginning. You don't want to have much latency there. Now, when you now speak about car data, that's a much more interesting thing, because you need more data bandwidth. If you have more data, you can actually bring from the car to the phone. And some of the data you may want to have in real time. So it's case with this. So it is, I think, one of the analysis what we at least see is that to be on the safe side, get something between 20 and 40 megabit per second, that should do it. So for example, that we see is even we support Bluetooth as an option. None of our members actually utilizing Bluetooth, besides using Bluetooth hands-free profile or ADTP for the audio side. But for the data connection, nobody's actually using Bluetooth, just because of the bandwidth limitations.
And honestly, to address the use of the specified transports, it really dates back to what is already prevalent and available in automotive production. Like going back to the whole development cycle. When we add new transports to automotive infotainment, we now have that long hardware cycle. And so by abstracting that in the IP layer, we actually add a lot more flexibility, a lot shorter development times into a go-to-market technology, something that automakers can use tomorrow, not 2 years from now.
I've got two questions. They might not seem related to begin with, but hopefully you can help me with this. Multiple smartphone devices with MirrorLink on them. How are they handled in the car? So if the driver's got one and the passenger's got one, how is that handled initially?
It's handled actually by the head unit. So the head unit would, if the head unit supports multiple phones, okay, it will have individual connection to the different phones. Okay. So the first thing what the phone actually does, it provides you a list of applications. What the head unit then does is aggregate those lists from the different phones and brings to the user. From a user perspective, you actually may not see whether the app comes from the head unit, from this phone, or from the other phone. Okay. So it's a sort of point-to-point connection. We don't need actually a really complex mashup.
And then I think related to the second question then is, has MirrorLink any current development vis-a-vis insurance telematics? Because that you're talking about two-way information coming from the car, usage telematics being a hot topic right now within the car industry. Is there at the moment within MirrorLink a development area for telematics, for insurance, for apps, for example?
So meaning that you collect driver behaving data?
Yeah, I mean, you look at in the UK, you've got the AA launching apps now for the phone to actually measure the way you're driving to give you a pay-as-you-go insurance.
Right.
That would be a natural development.
So so I mentioned, so with CCC working on be able to, from an app perspective, get access to the data. So this is one of the business model then as an app developer or as a service provider to actually write this app provided as a service to their customer using their car, collect the data, and use it to offload the data to the back end. Because at the end, what you have to see, still even the phone is connected to the car, it's still connected to the network. So you still can collect the data, process it, and if required, upload it to a central server to do some backend analysis then. So that's all possible. This is one of the use cases, one of the business opportunities for app developers to do.
And that's when you get back to the first question. You get two devices. I can then put it back to another room, somebody else's device. So I can actually pretend I'm driving and somebody else is behind. That's where it becomes tricky. You see, that's why I was asking the question.
Wait. But this is it's a tricky thing, but it's nothing what we can't solve, right? It's just the way that that part of that application you may need to have an authentication mechanism whether you are really driving or just a passenger.
Yeah, well, you have to know that insurance goes with the car, not with the driver, right? So. Not in the UK? Okay, all right.
Yeah. Well, that's something the authentication part, which you do them basically on the phone side. You work different mechanism there what you can have. And the important thing is there with regarding authentication. So we have mechanisms in where the head unit authenticates the device. So there we have mechanisms to ensure that actually the head unit is speaking with a MirrorLink enabled device which is compliant and certified and all that. So these are the mechanisms we have in place.
You mentioned before web services for communicating between the head unit and the mobile phones and the devices. I was wondering if you could get a little bit more specific. Are you planning on using web services? Are you looking at web sockets? Are you looking at secure protocols? Is this all wide open? I was just wondering if you could elaborate a little bit more on how the communication will happen and what protocols we'll use.
So at the moment, the access to the data, what we have specified is, or the concept what we have the notion of different services. So a service at the moment, we have specified basically two types of location services. One is a high-level location service. The other one is a sort of low-level, which is similar to what you have as if you would have a GPS mouse, which is NMEA data stream. Mm-hmm. You can then think of a sort of OBD type of data, or so you basically group them into data types which are relevant. So and we have a notion of these data services. What we have specified is a way to describe those services, how to start those services, how to control those basically, and we can provide the data over a shared connection. Yeah. So these are the mechanisms what we have in place.
Yeah, I think, but the advertising of the services through UPnP. Yeah, it's not their web service.
Okay, all right. Very interesting.
It's regular UPnP.
Okay, thank you.
And that is one thing what we try to do when setting up the different MirrorLink protocols is be as close as possible, even just utilize what's out there. That's why we said, okay, we need some advertisement discovery mechanism. UPnP does that, and it's available on the phone. It's nothing new, so therefore we hook to that.
So does that give you like an AirPlay style connectivity as well from Apple? Are you familiar with AirPlay, where you can just...
AirPlay?
Yeah, where you can just sit there and you can just flick something from your phone to the television or to the entertainment center?
Yeah, I mean, we've seen different services like that run on UPnP. So yeah, it's possible.
All right. So what about security? UPnP is not super secure.
Yeah, so it's a couple of things what you need to do, or what you can do is if you're worried about that the phone is running malicious software, we have mechanisms for ensuring this. So that the head unit authenticates the phone and that the phone is running compliant software based on secure boot and so forth. So we have that in place. If you're worried about man in the middle, we have mechanisms in place as well to sign UPnP responses. So we have the head unit asks for an action, receives some data back. That data back is signed with a key which is known, which is known to the head unit to decode. So we have those mechanisms in place to secure and avoid man in the middle, as well as having malicious software running on the phone.
Okay, good. All right, thank you.
Any other questions? We have time for maybe two more. No others? Any closing remarks, gentlemen? Well, with that point, in this case, we'll conclude our session here. Thank you all for attending the focus of the automaker value of MirrorLink. We hope you enjoy the rest of your Mobile World Conference and have a great afternoon. Thank you very much.